Welcome back to Trigonometric Functions of Any Angle, Part 2. We're going to start with some vocabulary, and we'll start with reference angle. Here's the definition of a reference angle. It's the acute angle theta prime formed by the terminal side of theta and the x-axis. So here's a couple examples. If theta is in your second quadrant, theta prime is this measurement right here between the terminal side of your angle and your x-axis. So if I needed to calculate this, what I would do is take 180 degrees, because 180 degrees is all the way over to here, and I would subtract theta, and that would give me theta prime. If theta is in the third quadrant, if my terminal side is in the third quadrant, my reference angle is going to be right here. This is my theta prime, and to calculate this, I want to take this angle and subtract 180 degrees, and that would leave me with this, with theta prime. If I'm in the fourth quadrant, here's theta, and my terminal side is in the fourth quadrant, my reference angle is right here, that's my theta prime, and to calculate that, I would want to take 360 degrees, which is all the way around, and subtract theta. So let's get a couple of reference angles here. 340 degrees. It's a positive 340, so I know that I'm going to go counterclockwise. And my terminal side would be about here. Now I know 360 is all the way around the circle, so theta prime must be 20 degrees. Because if I took the 360 degrees all the way around the circle and then subtracted the 340, I would get 20 degrees for my reference angle. This next one is in radian measurement, so I want to go to negative 15 pi over 4. Now a negative direction is going to be clockwise, and if you remember how we used our unit circle, this would be about pi over 4. That'd be negative 2 pi over 4, negative 3 pi over 4, negative 4 pi over 4. I'm going to go a little bit further. Here's negative 8 pi over 4, negative 9, 10, 11, 12 pi over 4, negative 13 pi over 4, negative 14 pi over 4, and finally here I am right here at negative 15 pi over 4. So this, if you were in degrees, this would be the 45 degree mark. And theta prime, which is my reference angle, is going to be this measurement right here, which would be pi over 4. If we were in degrees, that would be 45 degrees. But because I was given my problem in radians, I'm going to keep the problem in radians. So evaluating trig functions. This is what we want to do. First we want to find the reference angle. Then we want to evaluate the trig function at that angle, and then decide whether or not our value should be positive or negative. So when I say the value, I'm talking about the sine, or the cosine, or the tangent, or any of the reciprocal functions, the cosecant, the secant, or the cotangent. Now, if you remember, at the very beginning of this lesson, we did sine theta, and sine was y over r. So if I'm thinking about my first quadrant, y is always going to be positive, and r is the length of your radius if you had a circle, and that's going to also be positive. So no matter what, my sine is going to be positive in the first quadrant. Now cosine theta is x over r. So here in the first quadrant, my x is always positive. R has to be positive because it's a distance. So my cosine is positive. Tangent is y over x, but it's also sine over cosine, so you can think of it that way too. If you think of it sine over cosine, it's positive over positive would give me a positive measurement for tangent. Or you could think my y's are always positive in the first quadrant, my x's are always positive in the first quadrant. So tangent must be positive. When I'm in the second quadrant, my y is still positive and r is still positive. My cosine in the second quadrant is going to be negative because my x values are negative and r is positive. And sine over cosine would be a positive over negative is a negative. Or I can think y over x, which would also be negative over positive. I said that backwards, positive over negative. The sine down here in the third quadrant is going to be negative. The cosine would be negative. Both my x's and y's are negative. And because both my x's and y's are negative, my tangent will be positive. In the fourth quadrant, for sine, y is negative. My cosine, x is positive. And my tangent would be negative because a negative divided by a positive is going to give me a negative. So now I'm going to evaluate the tangent of negative 450 degrees. First thing I want to do is just sketch it. Remember, negative is going in a clockwise rotation. So if I go all the way around the circle, I'm at 360 degrees. And I want to continue that another 90 to get to the negative 450 degrees. So my terminal side is right here. My terminal side is the negative y-axis. My reference angle is going to be this measurement. So if you think about this, I went through 360 and then I went another 90 degrees. The reference angle is the angle that's formed from this terminal side to the x-axis. So that would have to be 90 degrees is my reference angle. So if I'm trying to find the tangent of 90 degrees, my reference angle, so I'm following these directions again, find the reference angle, evaluate the trig function at the angle, and then I'm going to decide its sine. I want to think about my tangent of 90. And remember, tangent is y over x. Now here's the thing. When you're down here on this negative y-axis, all of your values are negative for y, but check out what your values for x are. Every place along here, the x is 0. In fact, this line, the equation of that line is x equals 0. Now this doesn't make any sense. You can't divide by 0. So I can stop right here. My tangent at negative 450 degrees is going to be undefined. And that's what you say. You say that the tangent is undefined. You don't say error like your calculator would say. You don't say I can't do it. You don't say I don't know. You say it's undefined. The tangent, negative 450 degrees, is undefined. And one more. We're going to evaluate the secant of 19 pi over 4. So first what I want to do is make myself a picture so I can see where secant of 19 pi over 4 is. Sorry, I tried to move this out of the way and it just kind of got lost. So I'll try this again. Oh, also you want to remember, secant, the reciprocal of secant is cosine. So the secant of 19 pi over 4 is exactly the same thing as 1 over the cosine of 19 pi over 4. And I'm actually going to be looking at the cosine of 19 pi over 4 and then looking for the reciprocal because that'll make this such an easier problem. So what I want to do is find where 19 pi over 4 is. It's a positive, so I want to go in a counterclockwise direction. This would give me 8 pi over 4, 12 pi over 4. Whoops, I'm sorry. This would be 8 pi over 4, 12 pi over 4, 16 pi over 4. If I keep going all the way over to here, I get 19 pi or 20 pi over 4, so I want to stop right here. There's my 19 pi over 4. My terminal side is right here. And this is my reference angle, which is going to be pi over 4. So pi over 4 is my reference angle. Now I'm going to find the cosine of pi over 4. Now the cosine of pi over 4 is right here. Here's pi over 4. Cosine, you remember, is going to be x over r. So when I find the cosine, I'm looking for my x value and I'm dividing by r. Now, just as a side note, we're doing pi over 4. Let me just think about this right triangle. Pi over 4 is the same as 45 degrees. And you know that if you have a 45, 45 right triangle, that's 1, 1, square root of 2 are the special values for that. So if I'm finding the cosine of pi over 4, that's going to be adjacent, which would be, if I'm looking at this one, here's my adjacent over hypotenuse. So that would be square root of 2 over 2. That's my cosine of pi over 4. I didn't need a calculator. I didn't even need a, well, I used the triangle, but I didn't need a calculator at all to figure this out. I didn't need a chart. I was able to do it without that. So going back, my cosine of pi over 4 is square root of 2 over 2. So that means that my secant is going to be 1 over square root of 2 over 2. So the reciprocal would be this. And you know, you can't leave that radical in the denominator like that. So I end up with 2 square root of 2 over 2. These would reduce, and I get square root of 2. Now the only other thing I really want to remember is that I'm supposed to, after I figure out what the reference angle is, and after I find the value for the trig function, I need to decide if it's positive or negative. So remember, in the second quadrant, cosine is x over r, and my x is negative. So this negative, or this square root of 2, is actually going to be a negative. So that would be a negative, which would give me a negative square root of 2. And there I have it. So check out the next video, part 3 of 3.